All right, guys. So I want to make this video for you guys when you get to this point in your project where you have created your video. Hopefully you're in the process of uploading it to Flipgrid or have already done that. And now you're on the back page of your project and you want to try to create the equation for your object. So if that's going to be the case and we want to create that equation, we're going to have to introduce a form of an equation that we have not talked about yet called vertex form. Okay, usually what we've talked about up to this point is this form right here, y equals ax squared plus bx plus c. But now we're going to introduce vertex form, and this is going to help us take the information that we have and create an equation out of this. So here's what I would write on your paper here. I would just put this to the side if you have some room, is I want you to write vertex form down here. And this is what the vertex form of a quadratic is. It is y equals a times x minus h squared plus k. Y equals a times x minus h squared plus k. And we call this vertex form because the two variables in here, h and k, are always going to be the x and y coordinate of your vertex. The x coordinate of your vertex is always going to be h, y coordinate of your vertex is always going to be k. And so in this case for us, h is always going to be your time, and then k is always going to be your height. And so we're going to use that with the information that we've already gathered with your object here. So let's take an example here. Let's say I'm working in a group and we had a soccer ball that we kicked off the ground. It went up for a certain amount and then came back down. So we've talked about this. We said we want to find that vertex, and this is information that you should have gathered. So you should have gathered how much time it took to reach the maximum height and then what was the maximum height here. So for instance, let's say I kicked the soccer ball off the ground, and let's say we found that at 4 seconds, it reached a maximum height of 12 feet, for example. Okay? So this is our vertex, and we're going to plug this into our equation here in just a second. The other thing that we need to keep in mind here is our starting point. So if your group started your object on the ground, so whether that was like a stomp rocket or a ball or something like that you were kicking, your starting point is always going to be 0, 0, because the starting height would just be 0. If you're a group who maybe threw a ball, for example, you need to make sure to calculate how high the ball was when you threw it. So let's say, for instance, I have a group who we calculated and we saw that it was thrown when it was 6 feet high to start. Then you need to make sure your starting point is 6, 0. For this example, we're just going to look at when it's 0, 0. Okay, if you're a group who threw something, you'll do the same kind of thing. Just make sure your starting height is correct. So to find our equation here, first thing that we're going to do is we're going to plug in our vertex here, h and k. So I'm going to say y equals, okay, a in this case is not going to come into play just yet, so I'll just say a, and then x minus, make sure it's minus, and then h. So in this case, h, or our x coordinate, is going to be 4. So I'm going to say x minus 4 squared, and then plus k, so plus our y coordinate of 12. Okay, so I have my equation here now, and I can actually test this in a site called Desmos. Okay, you guys could also do this on your graphing calculators, but to make it easier for us and to see the instant results of the graph, I want you guys to use Desmos. So one of you guys in your group can go to desmos.com, and it has a graphing calculator that you can use, and that's on the main screen, so just make sure you click that button that says graphing calculator. Okay, and I'm going to type in the equation that we have so far. So I'm not going to account for the a, I'm just going to type in the x minus 4 squared and then the plus 12. So I'll say y equals x minus 4 squared, which I'll show you how to create the squared button on your keyboard if you don't know how to do that, and then plus 12. Okay, and I notice my graph is actually there, it's just not, or my graph is just zoomed in too far right now. If I zoom out, I can see that I have this parabola here, and my vertex is correct. But the problem with this is, number one, it's not facing the correct way, because if I look at my graph, I want it to be facing down. And then number two, even if I make it face down, so let's just put a negative out front here. Okay, I can make it face down, but it still doesn't go through my starting point like I want, because we want it to go through the point 0, 0, and right now it's not going through that spot. So what we're going to have to do is we're going to have to figure out what this exact number is going to be right here, or in other words, what a is. So I'm going to go back here, and this is the process to find what a is. You're going to take your starting point, so for us 0, 0, you're going to plug your x coordinate in for x and your y coordinate in for y. And the reason that we're going to do this is because once you plug those in, a will be your only variable remaining, and you can solve for that. So we're using this example here when our starting point was 0, 0, so I'll say 0 instead of y equals A times, instead of x, I'll plug in 0 for that as well, minus 4 squared plus 12. And now I just need to simplify this, and I'm going to try to get A by itself and figure out what that number is. Okay, and as a reminder, if you're a group who has a different starting point other than 0, 0, make sure you're plugging in the correct x value for whatever your situation is. So I'm going to go and continue with our example here. So I'll say 0 equals A, okay, and then I have 0 minus 4, so that would be negative 4, and then squared plus 12. Okay, we can keep going here. 0 equals negative 4 squared is going to give me 16, so this would be A times 16, or in other words 16A, and then plus 12, and now I just want to solve for A. So next step to solve for A, I'm going to subtract 12, so that it gets rid of it on the right side. On the left side, I have 0 minus 12, which is negative 12, and then equals 16A. And then last step here, divide by 16, and I'll get A by itself. A is going to equal this fraction here, negative 12 over 16. So first off, this is good because it's negative, which means our graph is going to face the correct direction. And then second thing here, I can reduce this a little bit. Negative 12 over 16 is the same thing as negative 3 over 4. And so that is A in my equation. So what I'm going to do with that is I'm going to take that, I'm going to plug it back in for A here. So I'll say y equals negative 3/4 x minus 4 squared plus 12. And now I can test that on Desmos and make sure that I did it correctly and make sure it goes through the spots that I want here. So I'm going to go over here to Desmos. I have a negative. I'm going to go 3 divided by 4. And now I notice that number is correct and it goes through the point 0, 0. So I can see my starting point is correct, my vertex is correct, and then if I want to find when it hit the ground, I can find that as well, and that'll give me all the information I need. Okay? So this is the idea of what you guys want to do. I'll post this example on Student View as well in case you just want to look off it or take notes off it, but I want you to use this idea, use your starting point, and find what A is so that I can get my entire equation. And of course, if you guys have any questions with this, feel free to let me know. All right? Thanks, guys.